Hello friends, today I would like to talk about the fundamentals of the basics of the vibration measurement and analysis. Why this very important condensation condition monitoring strategy that we always keep vibration measurement analysis at the top. Why? Because this is a very wonderful technology, and by using this vibration measurement analysis you can have a different type of problems and for the different situations. For example, you are doing the routine vibration measurement analysis of all the equipments, particularly rotating equipments. You may be having the periodic frequency of maybe every month, every 15 days, sometimes 2 months, and sometimes 3 months. How you are selecting this periodic measurement of the vibrations? Why do you think that one should take the every month, or why we should take every 15 days? The simple reason is that that you only concerned about the criticality of the equipment. When the equipment is very critical, you want to measure it 15 days. When the equipment is not so critical, that suppose a simple pump of the cooling water, or you can say not, you can say critical production, or criticality of the safety point of view, not hydrocarbon, something like that, unsafe. So based upon the criticality assessment, you have the maintenance strategy, and based upon the maintenance strategy you choose the condition monitoring. So condition monitoring, vibration condition monitoring is generally used for the all the high speeds and very critical machines, as well as the low speed very critical machines like reciprocating compressors, uh, or you can say all the general type of machineries like pumps and agitators, and having the, you can say, speeds of rpm from 3000 rpm to maybe 5000, 10,000 rpm, 60,000 rpm. That will come into the you can say compressors. And another, you can say, have a reciprocating compressor, maybe 500 rpm, 800 rpm, 1000. In a similar way, agitators you might be having a slow speed and then high speed. Now the question is, what is vibration? Why the people are saying that, why we should measure the vibration? Vibration actually a physical quantity where you have any machine designed, it will have a vibration. You cannot have vibration free any machines. The reason is that we cannot manufacture so precise, so some smooth, that it will not have any vibration, because it is rotating, and when you are rotating, machinery is there, some force vibrations are already there, and some excited vibrations are also there. Force vibration, in a sense, there's some external forces making them to vibrate, or some excitement, just like resonance frequency, or you can say the frequency at which some part is vibrating, having its natural frequency. So these are the things. The looseness may be the region. So the different regions are there for the vibration, and this vibration is the most you can say negative thing for any smooth operation of the rotating machinery. That's why we are measuring vibration. Now again, question is that the vibration, what is the meaning of the vibration? Actually, when vibration, we have a cycle, sinusoidal cycle, what you call, it is a sine curve. Means, I will give a simple example. The pendulum. In the old days, you might be having the clocks at your place at home. So you will have a cyclic harmonics type of pendulum. So what is the characteristic of vibration? Every vibration is having a wavelength or frequency and the amplitude. Now this amplitude, you can measure its displacement, you can measure its velocity, or you can measure its acceleration. All the three things are giving you can say insight about the vibration. Why? because displacement will tell you the stress, how much stress is there. Very high displacement is there of a particular vibration having a some frequency, it means there is a some stress. And the velocity will give the, you can say, severity in the terms of the amplitude also, as well as the frequency of the vibration. When we are measuring the vibration, we are not simply taking the sinusoidal curve or something like that. We are measuring complex vibration when it is a combination of vibration of different frequencies. Different frequencies means it may be in the harmonic of the RPM of the machine. Generally what we call it 1x. 1x means, x means the RPM of the machine. RPM means rotating cycles per minute of any machine. So in the terms of the frequency, when you say either you can say cycles per second, hertz, or you can say cycles per minute, or you can say revolutions per minute. So this frequency is very, very important, which type of vibration is coming, because it may be coming in harmonics of the main component, you can say main speed. That's why I would like to tell you that there is a one fundamental frequency of any machine, and then the dominant frequency. Dominant frequency means the main vibration from which part is coming, that is a dominant frequency. So in vibration there are three units, because anything you measure, it is a physical quantity. So in the physical quantity sense, the vibration you measure in the displacement. The unit is, you can say, generally in the old age it is a mils, it is related to the inch, and displacement may be measured in the mm or meters, and the velocity also in the meter per second or mm per second, and similar way is acceleration. So all the three quantities are measured depending upon the type of machines and the nature of vibration, the frequency of the vibration, and also the amplitude of the vibration. Because whenever whatever we are measuring you can say signals of the vibrations through the transducers, and we are taking this to the analyzer, where we are separating all the frequencies in a different all the frequencies of the signals in a different, you can say, vibration signals, and then plotting it. So there you can get in any measurement a overall amplitude. Overall amplitude means it is equivalent to you can say the total energy of the vibration, that is expressed in the root mean square, also RMS. So when you are saying RMS means or peak to peak, it is just somebody can take 0.7 something like that, because in the when you see the sinusoidal curve is a positive or negative both. So in a simple way, if you are going to add the energy, this will be plus minus, and it will not give. So that's why you are squaring it, and after squaring it, you are taking the RMS, root mean square. So root mean square will give you the exact energy of the different vibrations. So there are two things, what you call a time domain, means one side you are looking plotting is the time, and another side is amplitude, means x side time and y side amplitude of the vibration. So that is a time domain. Some people prefer to take the time domain, but it is always, the measurement is always in the time domain. And then when we are plotting, we can see the vibration in the frequency spectrum also. That is what called a frequency domain spectrum. Means in the x side you will have a different type of frequency, and in the y side you will have the amplitude of that frequency. So here again you will have in each and rotating machinery you will have a 1x, means 1x is there always, because it is a rotating, and that's why always the excitation is for the 1x. Now whether 1x is a problematic source is coming of the frequency, or somewhat else, maybe 2x, maybe 3x, maybe 5x. So depending upon the component, for example, if you are having the bearings, then you may be up, you can say multiple times of harmonics may be coming in the bearing side, because there is a wall, there is a race, there is, you can say, different type of speeds and different type of vibrations it might be generating. Other side you might be having the 1x because of the unbalance, misalignment, and you can have the looseness. The looseness may be because of the different type of harmonics they are coming, or your suppose the foundation, if there is a crack, so half axis is also coming. Sometimes you will have the not harmonics, that type of vibration also coming, but those are related to second different issues, maybe different type of looseness. So why this this vibration measurement analysis is wonderful? Because with the experience of the machines and the nature of machines, whether you are doing in a periodic way or you are doing in a, you can say, needed when there is any issue, any problem, then you are measuring, or you are just measuring for the monitoring purpose when there is a problem, or you can say before maintenance you want to measurement, so that after maintenance you measure, so that you can know in the comparison whether it any improved, any reduction in the vibrations. So there are maybe different regions of taking the vibration. For example, if I am there, what I would like to have, that for knowing the health of any machinery, first I would like to see this running parameters, operation parameters plus vibration is a must. Although I will see other parameters also like lubrication temperature, or you can say are different type of uh, other parameters, whatever it is. For example, in the centrifuge you might be having the torque measurement, so special requirements may be there. For example, in the centrifugal compressor you might be knowing where where it is running, how much IGV is opened, so you can know the flow also. But my way of looking the health of the any machine is to look its vibration, and all the machines are not having the online vibration monitoring instruments. Only the high speeds and critical machinery generally have, not general machinery. General machinery means pumps and all those agitators, also compressors also, sometimes reciprocating compressors also. So these they are not having the online also. There are different types of them, maybe proximeters, maybe balometer, or you can say another one is a vibration switch. So these are the different methods and different technology how by which you measure. Generally, Bentley Nevada systems you might be knowing very well are used for the online machinery, high speed machinery, and we are also having software related to that, which is known as very well known as a system one. There you can see the shape of the, you can say, orbits, or startup or cost down, what many information is there by which you can know the health of the machine. In a similar way, when you are taking periodically by some analyzer, vibration analyzer, you are measuring the vibration periodically, or you are measuring for I told you as the before maintenance or after maintenance to compare. There you can have a software where you can unload, and then you can say very beautifully see the time domain or frequency domain. Time domain and frequency domain you can see, this is very good, but you can have a, you can say, history of the equipment there, hierarchy of the equipment, and you can have a train of the equipment, you can see. Because vibration analysis is a skill. First you have to understand what is the vibration technology, then you practice it, and then by knowing the different problems, how they are generated, how they are developed, how they are showing in the symptoms as a vibration, how the, you can say, spectrum is changing with the time, how time domain is changing, that you can analyze and see. And why this expertise, you can know the health of the machine. Health of machine means you can know whether you should worry about it, or you can run for 2-3 months, or you have not to worry because it is totally normal. Fortunately, we have a different standards, different you can say methodology also, how to measure, how to analyze, and also standards for the vibration severity. So vibration severity, one should have depending on the type of they people have classified in a class 1, class 2, class 3, and taking into the consideration of how much power these machines are taking in the kilowatts, or you can say megawatt, and the type of foundation. For example, reciprocating compressors or centrifugal compressors, these are totally different machines as far as the vibration is concerned. So different type of vibration severity standards are there, but mainly the engineer who is very much interested in the vibration analysis, which is sometimes called as a rotating equipment engineer, or sometimes he is known as very well vibration engineer as well as reliability engineer. So there are different names, but the person should know not only the machines but how to analyze the machines and correlate with the other symptoms. For example, if the temperature is getting high, how the vibration is different, and whether a temperature is having any effect, or you can say flow, quantity of flow. For example, the cavitation will have a different type of a spectrum, or you can say uh, recirculation. Sometimes you get confused, because I would give you a very good example of 1x. 1x generally people think it is unbalanced, but no. If the xy is different, I mean x direction and y direction means horizontal direction or vertical direction, and axial direction, all the amplitudes are different. Plus the magnitude of the axial direction is very high, then you cannot say it is unbalanced. Most probably it may be misalignment. And also have to then confirm by measuring the phase of the vibration. Phase of the vibration, sometimes you have a ready-made in the high critical machineries, but in many machinery you don't have any already arrangement for measuring the RPM, or which is very necessary, or phase. All the, you can say, micro log analyzers, all those built in to have phase, because the phase is also needed for the purpose of the balancing. If you want to do the online balancing, that is also needed. So what do, you have a one equipment which is known as a strobe light, through which measure the RPM, and then through this depending upon the how the vibration is behaving for a one particular point in comparison to another point. For example, driving and motor bearing, how it is behaving with the driving and pump bearing. So with the measurement of both points in each direction, you can know, by knowing the vibration amplitude as well as the frequency spectrum and the phase readings, you can simply distinguish whether this 1x is really misalignment or unbalanced. So there, you can say, conformity tests also are there, but the best people are those who are continuously having, you can say, knowledge about the machines, behavior of the machines, productions, variations, and how the operators are there, whether they are really knowledgeable person, they know about the machines, they are tackling the machine in a proper way. Through all those things, experiences, you can know and tell. It is my experience and my confidence, because if you give me any machine, at least I can guess, and I can tell what is the problem up to the 4 or 5 months, or maybe sometimes 6 months. I mean, I have observed, monitored the machines, that depending upon the situations and how their behavior of deterioration is there, you can know what is the severity of the machine, what is the condition of the health of the machine, so that you can plan in a better manner. When you are knowing the severity of the machine, and then when you are knowing the condition of machine, you can very well plan. And when you are actually knowing from which component the vibration is coming, for example, it is coming from the impeller breakers, or it is coming from the foundation base plate breakers, or you can say any other casing side, or recirculation or cavitation, then you can have in a planned way, better way, you can treat it. For example, if the cavitation is there, you can look into the how the people are doing the operation, whether the liquid hydrocarbon having the high temperature, it is getting vaporized, yes, something, Or in other case, in the cooling water, we can see the recirculation is one of the main reasons. Recirculation means some leakages through the casing. I mean, the sealing is not proper. That's why wearings are not proper. So that's why the recirculation is happening. So in this way, you can analyze and see the condition of the machines by having good vibration measurement analysis program, plus your crew, and plus a very well developed library, how the things are happening, as well as the maintaining the failure history. So that's all from my side. I just want to emphasize that if you are a man of maintenance, if you really want to pursue the career in the maintenance, or already you are doing the maintenance, you must know vibration. Because if you are keeping separate from the people who are measuring, or you are keeping separate from the people who are analyzing, or your people who are vibration measurement fellows and analysts are there, they are not knowing about the machine, there will be always gap. There will be always gap, and the reliability will be in question. The person who is in maintenance must understand, maybe he is not doing the analysis all the time, but he should know the basics and the fundamentals, and should recognize whether the reports are coming are genuine or not, or whether the person who is doing the analysis, or you can say making the reports or giving the judgment about the condition of the machines, whether they have really know the machines, experienced or not. That is very very necessary. Thank you very much. If anything is there from your side, any comment or any sorry improvement you want from my videos, please tell. And thank you very much for today's video. Thanks.